There's a bridge in the middle of a small Greek city where, several times a day, the sea simply changes its mind. Stand on it and you'll feel water rushing beneath your feet at up to 12 kilometers an hour, fast enough that small boats can't sail against it. Wait a few hours and the current slows, pauses for a handful of minutes, and then reverses completely, rushing the opposite direction just as violently as before. This happens roughly 4 times a day, every day at a strait barely 40 meters wide. And for 6 or 7 days out of every month, it stops being predictable at all. The water changes direction not 4 times, but up to 14 times in a single day, with no rhythm anyone can set a watch to. This is the Euripus Strait, separating the island of Euboea from mainland Greece at the city of Chalcis. And it has been driving people slightly insane for roughly 2,500 years. It isn't just sailors and scientists who noticed. The phenomenon worked its way into philosophy itself. In Plato's dialogue Phaedo, Socrates reaches for the Euripus as his go-to image for instability, comparing the wavering, unreliable reasoning of certain thinkers to water that never holds still, never commits to one direction. When your local strait becomes philosophical shorthand for chaos itself, you know it left a mark on the culture that watched it. You'd expect the tide to just be, well, the tide. Predictable, gentle, twice a day, the way you picture it working almost everywhere else. That's exactly why the Euripus is so strange. The eastern Mediterranean barely has tides at all. Most of the Aegean rises and falls by only a few centimeters a day, an amount you'd need instruments to even detect. So when ancient sailors reached this one narrow channel and found the sea genuinely fighting itself, reversing violently, forming whirlpools at the turn, it wasn't a minor curiosity. It was a genuine anomaly, sitting right in the middle of the ancient Greek world's most traveled waters. The name itself carries the memory of that confusion in 2 completely different ways. One tradition holds that the word Euripus is built from Greek roots, meaning something like the strongly rushing, a simple functional description of water that never sits still. But another, older, stranger tradition claims the strait was named after a man, a wise old sage called Euripus who, according to legend, drowned in the channel while trying obsessively to understand why the water behaved the way it did. Whether the place was named after the phenomenon or the phenomenon eventually swallowed a man who gave it his name, nobody can say for certain. Either way, the story already tells you something about how this strait made people feel, not curious so much as haunted. And it didn't stop with one drowned, half-legendary man. Ancient sources record an impressive list of serious minds who traveled specifically to study the Euripus. The astronomer Eratosthenes, who you may remember as the man who measured the size of the earth with a stick and a well. The explorer Pythias, the philosopher Posidonius, the geographer Strabo, even the Roman statesman Seneca. This wasn't folklore for the uneducated. It was a genuine scientific puzzle that pulled in some of the most respected researchers of the ancient world, generation after generation, each one trying and largely failing to explain it. Which brings us to the most famous name attached to the strait, and the most persistent legend of all. According to a story that circulated for centuries after his death, the philosopher Aristotle, who had family roots in Chalcis, became so consumed with frustration at his inability to explain the Euripus that he drowned himself in its waters, supposedly crying out some version of, "Since I cannot understand you, you shall not understand me." It's a haunting image. The man who systemized logic itself, defeated by a narrow strip of water he could see with his own eyes every day. Here's the uncomfortable twist, though, and it matters, because this channel deserves the same honesty you'd want applied to anything else. The suicide story is almost certainly false. Historical records indicate Aristotle actually died of natural causes in Chalcis, and the drowning legend doesn't appear in any source written close to his own lifetime. It shows up centuries later, in the writings of much later authors, the kind of dramatic embellishment that tends to attach itself to famous names over time. Aristotle probably did study the Euripus. He almost certainly did not die because of it. So if the great philosopher didn't actually drown chasing this mystery, what was he and everyone else actually looking at? Here's what modern science can tell you, and it's genuinely elegant once you see the shape of it, even if the full picture is still being pieced together in the finer details. The tides that affect the Mediterranean don't arrive from local independent forces. They're the tail end of a much larger tidal wave that sweeps in from the Atlantic Ocean, traveling around the coastline. By the time that wave reaches the elongated, twisting body of water on either side of Euboea, it arrives at the northern end of the channel at a noticeably different time than it arrives at the southern end. That mismatch in timing creates a difference in water height between the two sides of the strait, And at the narrowest point, where the whole channel bottlenecks down to less than 40 meters, that height difference forces enormous volumes of water through a tiny gap. Fast, in whichever direction the pressure currently favors. Reverse the pressure, reverse the current. It's less a tide in the way you usually picture one, and more like two separate seas taking turns trying to equalize through a single narrow doorway. For most of the month, that mismatch follows a fairly predictable rhythm, which is why the Euripus usually reverses in a pattern you could almost set a clock to. But during certain phases of the lunar cycle, specifically around the times when the moon and sun's pull are least reinforcing each other, the timing of the northern and southern tidal waves shifts just enough to throw the whole system into the kind of chaos where the water can't decide which way to equalize, flipping direction over and over within a single day. Locals have a name for these stretches, the chaotic days, roughly 6 or 7 of them scattered through each lunar month, when the usual 4 times daily rhythm collapses into something closer to a dozen unpredictable reversals, one right after another. Researchers using modern hydrodynamic modeling, building on early 20th century work into water oscillation by the Swiss scientist François-Alphonse Forel, have gotten remarkably good at simulating the predictable days. The chaotic days remain genuinely difficult to forecast with precision, even now, with satellites and supercomputers that Aristotle could never have imagined. Which means the strait that supposedly broke the greatest logician of the ancient world hasn't been fully tamed by the greatest instruments of the modern one either. We understand the mechanism, we can model the average behavior, plot the tidal wave as it wraps around from the Atlantic, and predict with real confidence what a normal day at the strait will look like. But ask a hydrodynamicist to tell you exactly what the water will do on one of the chaotic days 3 weeks from now, hour by hour, and you'll get a much less confident answer than you might expect in an age that can predict hurricanes days in advance and land spacecraft on comets. Stand on that same bridge in Chalcis today, and you're looking at the same water that supposedly humbled Aristotle, that swallowed a half-mythical man who gave the strait his name, that pulled some of antiquity's greatest minds away from their libraries and out onto a narrow footbridge to just watch and wonder. The legend of Aristotle's death turned out to be fiction, but the thing that supposedly drove him to it was never fiction at all. It's still down there right now, rushing one direction and getting ready, in a few hours, to change its mind.